say there are 4 chapters. And so this AEE Western India chapter is one amongst the chapters in India. Other chapters are in Delhi, Kolkata, and now in Pune also. So it is basically for all the fraternity who are working in the field of sustainability and energy efficiency, and has many certifications like Certified Energy Auditor, Certified Energy Manager, then CMVP, and other, even if you are a renewable energy professional or you are working in water, so you have a relevant certifications for that too under the AEE, and these certifications are valid, are recognized all over the world. So if you are looking for international careers or already working into international careers, and then definitely these certifications will help you a lot. And in other than that, there are some signature programs of AEE and AEE World, and also the recognition awards that AEE gives every year in the month of September. So those awards are very popular. In the past, also many AEE Western India chapters members have received these awards, and this year also there are some 2 to 3 awards from India for AEE Western AEE chapters in India. And now let me introduce to today's speaker. So our speaker today is Shubankar Mishra, and he is heading the Baldur Reliance business in India, and he has an experience of more than 20 years in sales, marketing, business development, project management, and team management. He is a motor expert for over 15 years in sales, marketing, contract, and key account management of low voltage and medium voltage motors, and currently is responsible for business development for Baldur Motors in EMEAA region. And he likes to travel and explore nature escapes, including hiking and trekking. So long drives are a great stress buster for him, and also for many others also, that may be true with many others also. And now over to you, Shubankar, for today's session. So let's look forward for cooling tower direct drive solution, which is driving energy efficiency. So over to you, Shubankar.
Thank you so much, Bhavna. Well, a warm welcome to each one of you who have taken the time out to join and get into this discussion mode where I'd be presenting a novel concept. When I say novel concept, it's relatively new for the Indian market. It's been in offering for almost 2 decades, so more than 2 decades now in the US. But with the Baldur Reliance acquisition by ABB 10 years ago, we are now in a position where we can actively market these newer technologies into different parts of the world. And I'm a part of the international business development team sitting in Pune. I'm heading the business in India, as well as responsible for marketing the Baldur Reliance products across Europe, Middle East, Africa, and the Asia Pacific. So without more delay, I will just switch on my presentation. And if somebody can give me a heads up, if you can see my screen, just let me know. Okay.
Yeah, we can see your screen.
You can see the screen, right? Okay, yeah. Great. So good afternoon, everyone, once again. Okay. Yeah. So it's on presentation mode, right, Bhavna?
Yeah, it is in presentation.
Right. Okay. So a warm welcome once again. from Baldor Reliance Industrial Motors, part of the ABB Motion Group. Um, as a division within the ABB, we have our own mission to become the best marketers, designers, and manufacturers of industrial motors. We completely believe in the value quotient and delivering a high quality of perceived value. That means service quality with minimum response time and being competitive at the same time. Just to give you a brief of who we are in terms of Baldor Reliance, we are the number one global manufacturers of NEMA motors, essentially manufacturing in the US, more than 4,500 employees worldwide, employing a abundant percentage of our revenues to research and development. We have now, with the ABB acquisition, we are spread more than 80 plus countries. But essentially, the manufacturing is limited to the United States of America. And 1.5 years back, we acquired the Siemens NEMA business, which is in Guadalajara, Mexico. More than 100 years of experience in delivering quality products. It has gone through a lot of changes historically. Till recently, we were having both electrical, which is motors, as well as mechanical, which is Dodge. Dodge business, which was the gearbox and coupling, was divested in 2021. 2023, we completed the acquisition of the Siemens NEMA business, and here we are 100 years since we started the journey, delivering the highest efficient and reliable products. Just to give you a brief glance of what we do, we have a whole range of motors, right from single phase to three phase, AC to DC, including servo solutions, wash down duty, normal cast iron motors, specific HVAC motors, the direct drive motors, which I'll be presenting you today, marine duty motors. We are the largest suppliers to the US Navy. And we have the explosion proof motors, both in AC, DC, single phase, and three phase. So as far as the range is concerned, we have an unparalleled, unmatched range. Coming to the cooling tower systems, the principal question that is very interesting is, how do we move the air? When we talk about cooling towers, you'll find either it's a gearbox driven or a belt driven, and those are both very traditional ways of delivering high torque, low RPM. But each of these solutions, be it a belted solution, be it a gearbox solution, has its own limitations. In isolation, these are tried and tested methods, but it comes with their own drawbacks. Kind of cooling towers are we talking about? Vertical shaft top mounting is one of the most common cooling towers, and these are field erected and sort of wet cooling towers where the fan gearbox is completely exposed to a constant stream of air, vapors, be it corrosive atmosphere, but it runs on 100% humidity. When it comes to air-cooled heat exchangers, these are relatively the dry cooling systems. We also have the vertical shaft down, which are normally seen in the cement plants, which are the air-cooled condensers. Now, what here you see is typically how a wet cooling tower looks like. On the top of the cooling tower, you have an induction motor, which is typically a 4-pole induction motor. Now it is connected to a gearbox, which is sitting at the center of the cooling tower, which houses the fan. So what you typically see is an induction motor, which is running at 1500 RPM for the Indian conditions, connected by a long shaft to the gearbox, and the gearbox has a 90-degree transmission. The fan gets mounted onto the gearbox output shaft. And now this fan, based on what size it is, will vary for somewhere around 50 RPM to maybe around 500 RPM. When it comes to the traditional gearbox technology, it is nearly 100 years old. This is a very basic system and a reliable system at the same time. But having said that, it's 100 years old, and there has been only a degree of improvement when it comes to the overall system efficiency. It is characterized by usually a high associated maintenance because it is inside a cooling tower under very, very stringent conditions. Effectively, the efficiency levels are low. Why? Because there are many moving parts. It usually starts with a higher vibration because of its own mechanical limitations. In the larger cooling towers where you see a fan span of, let's say, 30 feet or excess, you have a very long shaft which connects the induction motor from outside the cooling tower to the center of the cooling tower. This often leads to the shaft failures, shaft bends, and inducing vibrations into the system. When it comes to the environmental impact, and in today's world, this context, it's become very, very important that we operate our systems in an environment conscious manner. If you see the extent of oil leaks, the oil contamination that surrounds the gearbox, it's really mind-boggling. And then also you have this issue of windmilling, where it can create a lot of stress on the gearbox. Inherently, these have a higher noise level as compared to a gearless solution. Here you can see, how a typical wet cooling tower gearbox operates, and it's laced with oil leakage and seepage. If you see on the top right hand corner, and these are actual site photographs, these are the number of oil drums that the client has to now dispose. Now, what we are talking about here? What we are talking about here is replacing the gearbox with a direct driven motor. What essentially is the function of the gearbox? It reduces the RPM and amplifies the torque. What if we were to have a motor which can deliver a high torque while still being capable to withstand the harsh environment that is there inside a wet cooling tower? What it means, because it's a direct driven system, the fan sits on directly the motor shaft. You don't have any moving parts. You just have one motor shaft which is running the fan. So less the moving parts, less maintenance, less cost, higher efficiency. So this is typically how a before and an after will look like. One thing that you may observe is the height difference between the motor body and the gearbox body. So typically when we are trying to move from a gearbox driven system to a direct driven system, it calls in for some retrofit. And this is where the game changes. This is where the customers need to be really very careful about the mechanical dimensional checks when we are doing the retrofit. How is it beneficial to the customer? Like I said, you have less moving parts, so you increase the reliability, you increase your uptime. There is less money spent on maintenance. You don't have any gearbox, you don't have any oil leakages. This is a grease lubricated motor, and you need to do greasing once in a year or twice in a year based on the size of the motor and the operating conditions. You don't have this long drive shaft. What this means is less pressure on your inventory. Because you don't have 90-degree transmissions and a difference in RPMs, you don't have bearing problems. Because this motor is going to run on a VFD, you get a soft start, you get a very smooth start. You have higher system efficiencies, better process control, less noise, less vibration. and it is cost effective when you consider the product life cycle cost. What are we talking about when we talk about the motor? It directly mounts the fan. You eliminate the gearbox, you eliminate the drive shaft. What kind of motor it is? It's a high torque, low speed permanent magnet motor. It's designed to be watertight because it's designed to be sitting inside the wet cooling tower. You can have multiple mounting options: vertical shaft up, vertical shaft down. You can have a horizontal mounting it as well. You can extend this application, this type of motor, to any application which requires high torque, low RPM. It is paired with the custom ACS 880 drive with a special cooling tower firmware. What does this do? It's a plug and play. We have a firmware specifically tailor-made for the cooling tower motor. It's easy to configure. It has got a trickle current function. What it does, it keeps the motor warm and dry even when the cooling tower is not in operation. It prevents the fan from the windmilling effect. How it does so is by the trickle current. It creates a magnetic locking of the motor which holds the fan firmly in its place. It doesn't require any encoders or resolvers, even though it's a permanent magnet motor, for this speed control and position control. It's got a de-icing inbuilt ability which keeps the fan blade ready for operation. Now, coming to the motor technology, how are we able to achieve it? At the heart of this motor is the permanent magnet rotor, which allows us to deliver the highest possible torque in a very, very compact footprint. We have a laminated frame, which allows us more active material and improved heat transfer. We have a VPI insulation scheme, which has been tailor-made or custom-made for the cooling tower application. Class H with multiple VPI cycles going into building a single motor. Coming to the sealing system, which is a primary concern, considering that it's going to be exposed to all the water droplets and the fumes. We have EnproSeal on the drive end. We have slinger support on the drive end in case any foreign object is falling, so it prevents a direct impact on the bearing housing. And you have a sealed non-drive end plate. We have a positive lubrication system which allows the grease to uniformly distribute even at the low RPM. So like, let's say for an example, 50 or a 60 RPM fan. In that also, the PLS system will ensure that the grease is evenly distributed in the bearings. We have something called wet assembly, where we take care of the assembly while still the parts are wet, painted wet. What it effectively means is when the paint dries, it seals off every pore possible. We have stainless steel conduit box, which is suitable for the harsh environment that this motor is intended to be in. Now, when we talk about the cooling towers, we also talk about the dry type air-cooled condensers, which usually have a blade span, the fan span of more than 30 feet. In this, you will not have a typical gearbox, but what you will find is that the fan and the typical motor is not in the same line. In some cases, you will find that the distance between the shafts, between the axis of the fan and axis of the motor, is well over 1.5 meters. And you will find that the motor shaft needs to be maybe even 4 or 5 or 6 feet long. What we do is we have for the dry type air-cooled condensers, we have two types. One comes with IP66 and the other one can be an IP23 for increasing the kilowatt and the torque ranges. What it essentially means is that we can cater to higher kilowatts, even like 150 kilowatt and a low RPM of 100 RPMs. What we are talking about here is a scenario, a marketplace where everyone is coexisting. You have the traditional setup of a gearbox with an IE2 induction motor. It's been there for 100 years, so it is definitely reliable. It requires a lot of maintenance, but that's how it was designed. When you want to upgrade from IE2 motor to an IE3 motor, you'll get a bit of benefit when it comes to a jump in the efficiency. And same for if you do from IE3 to IE4. But inherently, it doesn't solve your gearbox maintenance problems. When you couple it with a VFD and a direct drive motor, you can have very, very high level of efficiencies based on what your existing system is. We anticipate that by 2040, the number of motors in the world is going to double, and it accounts for 45 to 50% of world's energy consumption. So if we implement technologies which are more energy efficient, we can help reduce the carbon footprint. And this is what ultimately the aim is, to drive towards a sustainable future. This is what we want, to eliminate or reduce the carbon footprint that we have in our operations. How this journey started. This journey was started way back 30 years when Clemson University in USA was facing the gearbox issues, and they had approached Baldor that how do we come up with a better system? And this is how the cooling tower was envisioned. And for those of you who are not aware of what happens in the oil rigs, the cooling tower motor is derived from the top drive systems that go into the oil wells and oil rigs for the drilling rigs. So these motors have been designed for the harshest environment possible. This is what the journey has been. So we captured the voice of customer of the gearbox problems and came out with a solution. Presently, we have running more than 5,000 units across Asia Pacific, Europe, and Americas. It's a no-brainer that if you want to improve your system efficiency and system reliability, you must go for the best solution that is available. You couple it with an aerodynamic fan and a cooling tower direct drive motor that will allow your system to get to new levels of efficiency and reliability. I'm very interested to share with you the recent modernization case, what we have done in Rajasthan with the AEEWI group, where we were able to retrofit or upgrade gearbox solution to a cooling tower direct drive solution. And after nearly 2 weeks of running both the systems side by side, the customer was pleased to report energy saving of 28%. We have been catering the solution in India for almost a decade now. Our JW Marriott Hotel in Pune has benefited it by more than 30% energy savings, which is available on the 24th floor rooftop. These are some additional links that will be shared over emails to the audiences. And before I open the house for questions, we also have the unique IE5 plus EC titanium motors for the HVAC solutions to drive your AHUs and take them a notch level in terms of system efficiencies. So I think that's it from my side, and I'm opening the house for questions. I would like this session to be as interactive as possible. Let's open this forum for questions now.
Yeah, thank you, Shubankar. That was a great presentation, and Definitely, many of the users or system integrators may like to implement these solutions after looking up to these case studies and benefits of this system. So now I request for the attendees, like if they have any question, they can share it in the chat box, or they can raise their hand so that I can allow them to talk. Yeah. So let us have the questions. Yeah. Yeah, there's a question from Mr. R.L. Birla. So he says, what is the net savings for a typical 45 kilowatt fan drive in a ID cooling towers?
Okay, thank you for that question, Mr. Birla. The idea is that in order for us to predict the savings, we need to understand what kind of system you are running. Let's say you have a 4-cell configuration or a 2-cell or a 10-cell configuration. Okay, based on what your consumption pattern is over let's say a period of year. You in let's say for an example, you have a 10-cell system, and maybe you are running the 10 cells at full load during the summer time, but not so in the winter time. Maybe you are running it on full load during the daytime, but not so in the nighttime. So all these details need to be captured irrespective of the kilowatt. And when we are talking about a cooling tower direct drive solution, we need to be mindful that, let's say, the current solution is, in your case, 45 kilowatt. But is that a 45 kilowatt 4-pole motor running your fan? So in that case, we will need the fan RPM to then design the motor, because we are going to design the motor at the fan RPM. This is a synchronous motor. So there are a lot of variable factors. So if we are able to capture how your usage pattern varies, based on that, we can give you an optimum solution. Now, when we talk about how it is going to gain the efficiencies, I have seen customers say that my transmission loss or gearbox loss is hardly 1 or 2%, because that's what the data sheet reads. But that's not what we see in practice. So unless we do an actual audit of what your consumption actually is, not going by only by the paper, but actual readings at site, and then we come up with the solution. So it will vary based on how your loading pattern is and what kind of solution we offer, and what kind of usage you want to do. For example, I had visited one customer and one client, a petrochemical client in Uttar Pradesh, and we were talking about the benefits that you can do with by reducing the RPM and running all the cells together. And the gentleman said, "Hey, I'm not looking for energy saving. I'm looking to maintain a reliable vacuum in my system, which has far more positive ramifications on the compressor side, on the complete cycle." So when we talk about improving the efficiency, we can look at it at two ways. Either we deliver the same output by reducing our input cost, or using the same input cost, we exponentially improve our output. Either ways, the system efficiency goes up. So I'd be more than happy and my team to engage with you, capture the details, and then curate a customized product cycle cost for you, and take it from there. So it's not really very a simple calculation. We need to capture what kind of costs you're incurring for the maintenance, what's your inventory cost. So it's a lot of discussions that need to happen before we can actually predict what would be the net savings. But I can tell you, we can guarantee double-digit savings any day over a gearbox system without a shred of doubt.
Thank you so much, Shubankar, for that elaborate answer. And now we have question from Mr. Vivek Kaunkar. He says, with VFD and I3, how efficiency will increase by 60%?
So when we are talking about, let's say only efficiency, when we move from IE2 to IE3 to IE4, induction technology, effectively, okay, I'll take the question.
Yeah.
Mr. Birla, I'll just come back to you. So as I was saying, so when we talk about energy efficiency, okay, and we are talking about shifting from IE2 to IE3 to IE4, but on the data sheet, when you see 92% for IE2, let's say just speaking out or giving an example, the equivalent IE3 motor would be maybe, let's say 93.5. So that's a 1.5% jump. IE4 would again be, let's say 95. So again, a 1.5% jump, if that is how it is. And then the question becomes, how do we gain the efficiency? It's only improving my, thing by 1.5% on the nameplate. But when it comes to permanent magnet technology, and I'm talking only about four pole for, let's say, argument's sake. If you run the induction motor, a given induction motor at, let's say, 50% speed or 75% speed, an IE2 motor or an IE3 motor or an IE4 motor from 92, 93, 94% nominal efficiency at 50% speed would probably give you maybe 70% efficiency, or maybe even less than that. But when it comes to a permanent magnet rotor like ours, what happens is 96% efficient at 100% speed will become 94.5 or 94 at 50%. So the gain that a customer, that as a user you can have by using a permanent magnet technology, when your application is having the partial speed possibility. So if you upgrade from an IE3 motor to a permanent magnet motor, and you don't intend to use the variable speed, you will not gain energy efficiency. Its energy efficiency is best when you implement the VFD, because the VFD is going to do wonders, because the power consumption is proportional to the cubic. So when you reduce the speed to 90%, your power consumption goes by 0.9 into cubic proportions. So for example, what I was trying when I was earlier addressing Mr. Birla, let's say you have a 10 cell system, and during the winters you switch off 2 cells in your current, I'm assuming that you have a direct online system, okay? So what you do in the winters, you don't need that much cooling. So what you do is you switch off 2 cells and you're running 8 cells with 100% power. So that's 80% of your power, 8 cells into 100. But what we say is, why don't you run all the 8 cells, all the 10 cells, 80% speed? So if you do that, your power consumption goes to 64%. So you are already saving 16%. If it was a 7 cell or a 6 cell and you reduce the speed to 70% or 60%, you'd get cubic savings proportion to the cube of the reduction of the speed. So that is how you get the efficiency gains. But you need to be mindful, we need to be mindful whenever we are talking about energy efficiency gain, that if you just switch a direct online system with a permanent magnet motor, or even an IE2 to an IE4 or an IE5 or an IE6 motor, and you don't intend to reduce the speed, you will not get efficiency gain. You change it to any make of motor, you will not be able to gain the efficiency that you're supposed to gain with a speed control. So the speed control is the essence. What the cooling tower direct technology does, in addition to this, to the efficiency gain, you are also eliminating the mechanical parts. Each of the part has its own losses. The gearbox has its own loss. Over the years, the degradation happens. The long transmission shaft for, let's say, a 15 feet radius fan, you have a shaft which is running at 1500 RPM. It has its own losses. You have the couplings. All you are eliminating the complete transmission chain, and that's where you get the double-digit savings. So couple it with the VFD or the partial speed gains, you will be able to get a very handsome energy saving. I hope I've been able to address a bit of the queries.
Yes. Yeah, I hope Mr. Vivekankar, your query is satisfied. And now we have next question from Tejveer. What about impact in corrosive or slime ambience?
Yeah. So like I said, this motor was conceived to be inside a wet cooling tower, exposed to fumes, exposed to the stream of water that is continuously given. And I can tell you for a fact that the first installation that we did was a wet cooling tower in Ruchisoya, Kakinada. And if anyone were to reach out to that customer, he can confirm that they have not taken that motor out even today. And it's running 12 years, still going strong. All they have to do is grease it once in a year during the annual shutdown. It has had no failures till now. So, and these motors are IP66. We use a paint system which we use for the US naval duty motors. So I can tell you for a fact that the paint system is robust. It is not C5. It is not C5M. It's a wet paint system developed by Baldo Reliance only for the cooling tower direct drive solution and the Navy duty motors. So we don't use this paint system in any of our other motors.
Yeah, interesting. I hope Tajveer that answers your question. And now next question is from Jabamani Tamilarasan. He's asking about payback period for retrofit cooling tower, which you showed during the presentation.
I can tell you that we are so one thing is that we are manufacturers based out of the US. Any Baldo Reliance product that comes into India is manufactured in the US. It goes through the shipment cost, it goes through the import duty cost, and then as ABB, I have my own overheads, own salaries to pay. And yet I can tell you that the payback period that we aim is somewhere around 2 to 3 years. We understand, we are mindful that any product that we are pitching, even as good as a cooling tower direct drive or an i5 motor, i5 EC titanium motor, the payback needs to be reasonable and in line with the industry standard. So anything that we are trying to sell, if it's out of 3-year mark, customers are not going to invest in it. So typically we try to limit our ROI to 3 years, but then we need to be mindful that we need to quantify your actual maintenance costs transparently. That's when you're going to get the savings. And imagine that once you've done the payback, what about the next 10 years that you're saving so much? So we also bring in the angle of the product lifecycle cost. But it requires a retrofit, without a doubt. It requires a retrofit. It's not a simple fit where you remove the gearbox and put it. There has to be a certain degree of responsibility while we are doing it, in terms of strengthening the structures, in terms of creating the new base plates and everything. So all that has to be taken care care of in a mindful manner.
Thank you. And now next question is from Mr. Amitabh. Is asking, direct drive motor can be installed with FRP fans. What percentage of savings of motor input power can be achieved?
So let's say there are two scenarios where a customer buys has a cooling tower fan, which is maybe 10 to 15 years old and has a metallic fan. So what are the various options that the customer has to increase the efficiency? The very first the basic answer is the change from a metallic fan to an FRP fan. The moment you do that, you have maybe efficiency gains plus 20% maybe savings. You also couple it with an aerodynamic FRP fan, you get a bit more. You put in the direct drive motor, you further get another double digit. So it all depends on what you are looking for, what kind of retrofit you are willing to invest in. That will give you the answers. So we have with us multiple cooling tower retrofit partners that we utilize, because essentially we need to be mindful that as ABB we can take care of the motor, we can take care of the drive, but when you're talking about cooling tower, it's a complete system. So we have partnered with experts in the field who help with the reliability studies, with giving you a complete solution, and ABB can support that.
Great. So now after this, so Mr. Amitabh, I hope you are satisfied with the answer. And Vishwajit Nath is asking, on energy efficiency point of view, how will it be benefited?
Well, it's a to Vishwajit, I just say that it's a no-brainer. In a gearbox system, you have multiple moving parts. Each of the part has its own losses. You're eliminating everything, so you will benefit. You will have double-digit savings. If you look at gear belted solutions, belt is the weakest link. The belt is an inefficient way of moving air. So if you eliminate the belt drive, again you're going to get savings. So double digit savings, 100% assured. That's what we have seen in every single case of a retrofit that we have done in India. uh, if I can just answer Tajveer a bit later, I'd like to come back to Mr. Birla because he's raised his hand and he's been waiting for quite some time. Mr. Birla.
Yeah, so let me allow him to talk. So Mr. Birla, you may ask your question now.
Or if you don't have a follow-up question, I'd be happy to answer it offline. If you can move ahead and
his question is regarding experience of this drive, life of the motors typically in India.
These motors have a design life of at least 20 years, even with the harsh environment. The bearing selection is done. We are mindful of the fan weight and the thrust load that it's going to come. And even with that, the bearing life, the Elton life is 1 lakh hours.
I hope, Mr. Birla, that answers your question. And email addresses of Mr. Shubankar he has shared. So if you have further questions, you may write to him. Now, Mr. Tejveer had some question, right? Yeah. So Mr. Tejveer is asking maximum motor efficiency of 15 kilowatt motor.
It will depend on what is the RPM that you need. So 15 kilowatt 100 RPM motor will have a different efficiency than that of a 15 kilowatt 350 RPM. So like I said, this is going to be designed at the fan RPM. It's not a 4-pole motor or a 1500 RPM motor that we are using a VFD to reduce the speed. It is going to be designed at the exact fan RPM. If you have a fan which is running at 101 RPM, we can design the motor at 101 RPM. If you have 101.5, we can do it at 101.5. That will be the synchronous speed or the design speed. So, I mean, it's a very open-ended question. Motor efficiency of a 15 kilowatt motor. So Tajveer, if you can just elaborate on what exactly you want, so that I can answer in a better manner, maybe.
Yeah, Tajveer can take this offline, maybe, because it's a very specific question. And let us move forward. Mr. Birla, we have answered. Again, Mr. Amitabh is asking, this motor will work for forced draft and induced draft fan of
Yes,
cooling tower and boiler.
This product is designed for induced draft. It doesn't have any fan internal or external to it. It utilizes the draft air for cooling. And when you are considering cooling tower, the center part, so typically in a cooling tower, the as you come towards the center, the airflow is very, very less, and the design considers all of that. So for let's say 350 RPM, the airflow that we typically consider is 750 feet per minute. But if we do a 100 RPM motor, we will typically go for a 250 feet per minute airflow, which is a very, very safe selection.
Yeah. And now Mr. R.L. Birla is again asking, is the DDs not manufactured in India at present?
Not at present, sir, but we have a local warehouse where we stock a lot of motors, not cooling tower direct drives, but if let's say uh, typically the lead time of these motors, the X Works lead time is around 6 to 8 weeks, and then I have the shipment. Normally we are getting it by air just to save some time, but we are open and flexible to support the customer in any way that they want, including local stock. So like for typically if we are talking to an OEM, a fan OEM, he would ideally want to build up local stock so that there is a regular supply. So we are mindful and flexible on how we wish to operate and market this product.
Okay. Mr. Kiran Kumar is asking, any BLDC motors in cooling tower fans? If BLDC fans are available, up to what capacity of fans are available in the market?
I'm not very aware of the BLDC fans in cooling towers, but I can tell you that we have seen a trend where there is something called a newer technology which is coming up, which is called adiabatic cooling towers, um, and those are very small cells, compact cells where water is scarce. It's more like if you have seen those silent DG sets, but you'll have a 16 cell pack or a 18 cell pack uh, to eliminate one single gearbox, a large gearbox solution. Uh, but we are not into that. We have motors like exterior rotor motor for that application, which are IP65, but we have not partnered for that product as of now in India with anyone. But we are looking to partner. We are looking at various HVAC solutions, not limited to cooling tower direct drive technology.
That's great. Now we have a compliment for you, Mr. Shubankar. It's a very good seminar needed for the HVAC world. And also a question, do we have similar solutions for VRF systems for commercial buildings?
VRF. So I can tell you that we are talking with some of the global players who are for the VRF, who are providing VRF systems. But we have a whole range of what do you say solutions for the HVAC market. Bhavna, would this platform be appropriate just to show a couple of slides on that?
Oh, sure.
Okay, I'll just take a minute to digress from the main agenda, but because this topic has come up, I'll just take the liberty to show something. Let me know if the screen is visible again.
It is visible.
Okay. So within the Baldor group, we have something called the Integrated Motor Division, where we are looking to deliver compact integrated solutions for the HVAC. Here you see a plethora of products on the bottom. Let me use the pointer. So this is the EC Titanium IE5 Plus range that I was talking about. These are the permanent magnet synchronous reluctance motors, 1 to 20 horsepower, HVAC, AHU application, the sweet spot being 5 to 10 horsepower. This is the exterior rotor motor. This has been launched already. You can see the complete array on the right hand side. This is something related to the HVLS fan. And on the centerpiece, you see something that is going to be launched next quarter, is called the squirrel cage motor that you find in the FC units. So customers these days are moving from the traditional gearbox cooling tower to something like this that you see, and this is where the ERH comes into the play. So currently you have the PC fans which are being used for this. So the EC Titanium comes with a motor only configuration with an axial mounted drive and a top mounted drive. The best part of the motor only solution is we are delivering i5 plus efficiency. The service factor is 1.5. So that's 50% overload capacity. And you can run it with not only an ABB drive, you can run it with a Danfoss drive, you can run it with a Yashikawa drive, you can run it with a Siemens or a Schneider or a Rockwell drive, any drive. The drive needs to be permanent magnet suitable and Cinerem suitable. Two logics. ERH. This is something that we have again launched recently. We are using the i5 efficiency with AC brush sensorless technology. I'd be glad to share the technical details to anyone who needs to understand this and have a dialogue with my team. This is something that we are coming up very shortly, which is the squirrel cage motor, like I said, for the FC units. And this is for the HVLS motor. Currently, the fans that you see in large open areas and airports, you have this fan which is running at a very low RPM. Then the whole idea of that fan is to evenly spread the cooling across a wide room. But effectively what this has is a gearbox. What we are doing is we are eliminating a gearbox. So some exciting products coming from the house of ABB for HVAC.
Great. Yeah. So I think yeah. So that was a very interactive session, and the presentation has generated a lot of inquisitiveness about the ABB products used for cooling tower and HVAC. And so I hope all the questions have been covered. And regarding contact details, email address is shared in the chat box. You may note it down. And regarding this presentation, it will be uploaded on our YouTube channel, that is AEEWI Western India, Western India on YouTube. So we have a channel where all the previous presentations are uploaded in the form of recording. Yeah.
Before we sign off, I see Dr. Hitesh raising his hand.
Oh, let's.
Yeah. Dr. Hitesh, if you can share your query. What you can you can unmute, sir, now.
Yeah, Mr. Hitesh, Dr. Hitesh.
Is I think he's on mute. So
Yeah, you will have to unmute, Mr. Hitesh. Oh,
I
I
think
think lowered also.
no
There's some.
worries. I think anyone who wishes to reach out, feel free. I have a team with me. We'd love to engage on this topic, HVAC and cooling tower direct drive solution. Definitely, it's a new team, and we are really geared up. Especially now that we have proven the savings with the customer, and very recently, so we are really keen on uh, talking to more and more people, creating awareness. Dr. Hitesh, you can speak. We still have 2 minutes to go, but yeah, I think Birlaji, are you saying something?
Just wanted to tell you, are you able to listen?
Sir,
Yes, sir. Yes, sir. It is audible. Am I audible?
both of you are audible, sir.
Okay.
Great. Yes, sir. Good afternoon. Sir, just a small doubt whether this variable frequency drives are going to get affected because of this invention. That was just a small query.
The regarding the HVAC you are saying, or
Yes, it's wherever electrical motors are used, if there is a load variation, for example, usually in compressors.
yes.
So we usually tend to recommend the VFDs. So that's just my side query about it.
So the whole idea of moving more and more towards VFD driven technology is the energy saving that a user can have instead of running on full load always, because with dual you don't have the bandwidth to reduce it, but with VFD you can have it. So the whole idea is we are seeing a tendency of more and more customers moving towards VFD driven solution. In fact, I can tell you that in the Middle East, uh, they're trying to. There is a conscious effort to spec in all low voltage motors above 1 horsepower should be VFD duty, and and because they realize that even with, let's say, the additional burden that comes with having a panel room and providing a safe environment for the VFDs, the the pros outweighs the cons. So every single technology has some drawback, right? So I cannot say that a Baldor motor, you fit it and then absolutely 100 years nothing's going to go wrong. It's an electric motor at the end of the day. But whichever brand we choose to take, every brand has a pros and cons. How we solve a problem is the key. How we support our customers is the key.
Yes, sir. Thank you. Thank you, sir. Thank you.
Can we talk now at the moment?
Yes, absolutely, sir. I know we are short, but I'll take this one last question from you, sir, please.
Well, we have got quite a lot of plants where the existing system is being used either by Park or any other manufacturer.
Yeah,
It is basically designed with respect to the gearbox.
correct.
Two things which comes into mind, because no plant is going to get convinced immediately by the new drive. So first of all, we need to consider whether we can simultaneously one of the towers, say out of the four or out of the three, one can be converted and seen, because the plant also needs to be convinced. It is not.
That's how it's supposed to be done, sir.
No, that's right. So basically, what we need is that we can at least try one cooling tower on this and convert the system and see what kind of saving are achieved. Once it is convinced, there's a lot of market in India. Because almost all
That's
the
the whole idea, sir. That's the whole idea. This session
yeah,
that
I know the cooling tower because I've been closely connected to the captive power plants.
Yeah.
And we find that a lot of drives which are there, they are basically gear drive only.
yes,
The things which arise in my mind is regarding the loading, because this is the motor system is able to take care of the load of the complete fan. So fans are going to be given by the OEMs.
I can tell you when we are doing the retrofit, you don't need to change the fan hub at all. The motor will come with a custom shaft to match the gearbox shaft, output shaft. So the fan hub is going, the same fan with the fan hub is going to sit on the motor shaft.
I got no doubt about the fan sizing. On the shaft size, I got no doubt. I have got only a doubt regarding the loading of the, because the fan hub is quite heavy. It may be something like more than.
Sir, we have installations, and I can share the global references. We
Even
have done fans for like 30 feet fans as well. So
we'll contact you. There's absolutely no problem.
sure, sir. Looking forward to it.
thank you so much, Mr. Shubankar Mishra, for the wonderful presentation and patient answer to all the questions of the attendees. And thank you, most importantly, all the attendees who have been attending this webinar since its starting, that is January 2023. Some of you are very, very regular, and that's really gives us a lot of motivation to continue this webinar series. And next year, again, we will be continuing this, and we will be having a new format also, adding a new format to this. So also we would like to have feedback regarding this webinar of how you would like to have this more interactive or more useful from the user's point of view. Yeah. Thank you.
A lot of new subjects in fact by you.
Pardon?
Thank you very much for bringing the new subject in the light, because basically sharing is very important for us.
Yes, definitely. We always try to bring in new subjects, and if you have some specific subjects in mind, so definitely do let us know. We will try to arrange that also. Yeah.
We will do that. Thank you very much.
Thank
you everyone for this.
Thank you, Bhavna ji, for this opportunity.
Yeah.
It was a pleasure being here.
Thank you so much. And thank you, Mr. Kadam, for arranging this webinar from ABB. And we hope to continue this association in future also. Yeah. Thank you.
Yes,
thank you, Mr. Shubankar, once again. Yeah.
Thank you. Thanks. Bye.
Bye.
Bye.